This is CPM Calculus Chapter 4, number 51. What is the equation of the vertical line that will divide the integral from 0 to 6 of 5 dx in half? Is that the same line that will divide the integral from 0 to 6 of 5x, right? 5x dx in half. So remember that the integral from 0 to 6, 5 dx is just looking at the area between the line y is equal to 5, so that's 5, right? 0, that's our x-axis, y-axis. So the area between 0 and 6, right? And we know that this is equal to, well, the base of this rectangle is 6, the height is 5, so 5 times 6, or 30 units squared, right? And we know that if we cut this in half, right, that will cut the vertical line that will cut it in half will be at x is equal to 3, halfway in between 0 and 6, right? So, and that will make 15 here, 15 units here is the area, 15 units squared here, because we divide 30 into 2, right? So we know this happens. What is the equation of the vertical line? Well, this equation of this line here is x is equal to 3. That is the equation of the vertical line that cuts this in half. All right? We can even test that. We could take the integral from 0 to 3 now of the same function, 5, and the area is then going to be, the base now is 3 here, the height is still 5. 5 times 3 is 15 units squared, right? So that is half. So this is the line that cuts this region in half. So then we're asked, is that the same line that will divide 0 to 6? So our integral from 0 to 6 of 5x dx in half. And remember, this right here is going to be the line y is equal to 5x. So the slope is 5 over 1, and our y-intercept is 0. So it's going to be like this. It's going to be pretty steep, right? This is our line, right? This is the line y is equal to 5x. And this is 2, 3, 4, 5, 6, right? So this right here is the area underneath the curve here, right? And they're asking, well, is the line going to be at x equals to 3 going to cut the area of this side and this side equal to each other, right? Is this going to cut this region, this triangle in half? And right away I can see that no, it's not, because this area is definitely less than this area. Well, let's go ahead and figure this out, okay? So again, this right here is equal to the area under the curve, and we know this area is what? The base of this is a triangle, right? So it's equal to 1/2 base times height. 1/2, well, the base of the triangle is 0 to 6, so 6 units. The height of the triangle is, well, when I plug 6 into x, right, I'm going to get this point here. So that point, the y value, or the point is 6 comma 5 times 6 is 30, right? So this height is 30. So 30 here. So half of 6 is 3. 3 times 30 is 90. Okay, so 90 units squared is the area of the triangle. If we were to cut this in half, right, we would want the area to be 45. So half of this is 45 units squared, right? So what is going to be the ending point? Let's call it x. If our equation is 5x dx, when is that going to equal 45? Right? We could solve this equation for x, and that will tell us what line we should make that will vertically cut the region in half. All right. So what is going to be the area of this? This is going to be the area of a triangle, but now our stopping point is x, right? So our height at the stopping point is going to be 5 times x. So the area is 1/2. Base, we're going from 0 to x, so base is x. The height is 5x, and that's equal to 5/2 x squared. And we want to know where that is equal to 45. Okay? So where is that equal to 45? Well, let's multiply both sides by 2 over 5. So if I multiply this by 2 over 5 and 2 over 5, I get x squared is equal to 45 over 5 is 9. Wait, 45. Yes, 9. So that's going to be 9 times 2 is 18, right? And so we can go ahead and square root both sides, and we get x is equal to plus or minus square root of 18, right? But we know x, actually, x can be a negative value because it can cut it in half here, right, if the vertical line is over there. So this, let's simplify that because we know that's plus or minus 9 times 2, or plus or minus 3 square root of 2. So x can be plus or minus 3 square root of 2 and cut this in half, right? Just like another solution here would be negative 3. X equals to negative 3 would also cut it in half because, well, oops, not negative 3 because we want to cut the region from 0 to 6 in half. So actually we want to cut the region 0 to 6 in half. We don't want negative as well. We want just x to be 3 square root of 2, right? And that is definitely not the line x is equal to 3. That's the line x is equal to 3 square root of 2. So the question asks, is it the same line? No, it is a different line. Right? No, it is a different vertical line. Another way we could have done it is to test. Well, what is the area between 0 and 3 of 5x dx, right? This is the function we have here. And if we test with 3 being the end boundary, that's just going to be the area of our triangle, right? This is 5x, the line that hits at the origin. And if we look at 3 being the end point, we're just looking at that area. That's equal to 1/2 base times height. Again, it's a triangle. The base is 3. The height is this distance. Well, we plug in 3 into 5x to get that height. So this point is 3, 5 times 3 is 15. So multiply by 15. Right? And we get 1/2 times 3 times 15 is going to be 45 over 2. Right? 45 over 2 is 22.5 units squared. And does that cut our region here in half? No, because half of 90 is 45, not 22.5. Right? So again, no, it's a different vertical line. We've done it 2 ways. We explained why it's no in 2 different ways. One, we found what the vertical line should be. It should be x equals 3 square root of 2. We also checked, well, if we use 3 as the vertical line, if x equals 3 is the vertical line that stops our graph, like we're looking for the area between 0 and 3, then our area is just 22.5 units, and we're expecting the half to be 45 units squared. All right? So that ends for us CPM Calculus Chapter 4, number 51.